So our project is called Sensor Technology Fusion for Online Monitoring and Control. But the most important is to introduce our ESR. It's Hendrik. He should be in the room with you now. He started 2 weeks ago, and he did his MSc in the group of Felix. In fact, at TU Dresden. Quick look on our campus. So this is our campus in Wageningen. I guess you do not know where Wageningen is, but Wageningen is a small town. In the province of Gelderland. It's very close to a side arm of the River Rhine. You can see on this picture here. Then about our project. We want to focus on online mass balancing. What do we mean with that? We will focus on, say, the general growth reaction of algae. So CO2 plus water and nitrogen giving biomass and oxygen as a product. So we actually want to use a state-of-the-art sensors. So it's a bit a pragmatic approach using the best technology available at the moment to be able to, we want to measure, say, simply oxygen exchange, CO2 exchange, nitrogen uptake. And from that, we want to calculate in real time, what is the biomass production rate, what is the nitrogen uptake rate, oxygen and CO2. If we compare that, those signals, then we can also assess the degree of reduction of biomass. So we should correlate to the biomass composition. So biomass rich in lipids, for example, should have a higher degree of reduction than biomass rich in carbohydrates. Also, the nitrogen content in the biomass could be assessed online in real time if you monitor the nitrogen uptake rate, which we aim to do. And we also want to have good insight in the light absorption in the culture. So we also can say something in real time about, say, the efficiency of light use. And we also developed a technology to measure the respiration in the light. So by a sensor in a dark tube within the reactor, we can also, while the algae are doing photosynthesis, bring a small volume in a dark tube and measure the respiration, which is occurring also under limited conditions, which can be quite important to assess, say, to have a good insight in the metabolism. So we want to focus a lot on accuracy because these are known techniques. They also applied, but often I think they can be applied in a better way by paying attention to the accuracy of these sensors. And for that, we have to work on, say, automatic calibrations, and maybe include additional measurements to create some redundancy and to filter out errors in our signals. And maybe you can integrate offline measurements like dry rate analysis or carbon, organic carbon measurements, to recalibrate our sensors, say in a daily basis. And for what can we use then these tools? For many things. So you can use such a reactor tool with all these monitoring options to study growth as a function of light regime, temperature, maybe levels of dissolved oxygen and dissolved carbon, how you operate your reactor, how do you dilute the reactor, and many other things. And that's also where we can connect to many other projects within this consortium. Very quickly, it's not official yet, but we are planning to do a workshop also this summer, probably in July, but it will be announced to you later. But we will also organize a school on microalgae process design.